Does there exist a quadratic equation whose coefficients are rational but both of its roots are irrational? Justify your answer. So the question is quite simple. Does there exist even a single one? So what can we do? We can give a simple example and we are done. Okay, please understand what is that we have to prove and how is that we should be proving. So a single example will suffice. So basically the funda is this. We have, see, this is something that I have to think on a rough manner. So I'll make the rough work somewhere else. So we want the roots to be what? Irrational, while the answer is rational. Okay, means we have A, B and C to be rational. Is it not? Please look at the question. Whose coefficients are rational but both the roots are irrational, right? So we can take alpha to be say root 2 and beta to be say root of 8. So we have alpha plus beta, which is minus b by a, and alpha into beta is c by a. Okay, this method is not working out. See, this is how I think also. I'm showing you guys how to think. So that is a bit too lengthy. Basically, I scratched the paper. Then what else can we have? Okay, I'll go with say 3x square plus 4x plus say 2. So d for this case is 16 minus 4 into a is this and c is this. So this will be, okay, I'll go with 5 over here, and this is 25. 8 is 24, so d is 1. Square root of 1, that won't help us. 6, 36. See, d I'm trying to make it as a root value. If it's a root, then by default alpha and beta will be roots. So this again is 12, 24, 24 and 12, right? I hope I'm right. Yeah, 12 multiples of 12. So clearly here alpha and beta will be roots. Okay, that's it. Just write this answer and you're done. So I'll tell, let's consider. See, the funda is, it all depends on what? It all depends on d. Work out d value, get it to be of a form which is what? Which is whose square root is not there. The root of that number is an irrational number. Right, guys? Because here under the formula, quadratic formula, we have root of d. So we are trying to manipulate d. That's all. Let's consider a quadratic equation. 3x square plus 6x plus 2 is equal to 0. So d for this case is b square minus 4ac. So b is 6 square minus 4 into 3 into 2. So we have this to be 36 minus 4 3s are 12, 24, and the difference is 12 itself. Then we have x, which is nothing but your alpha and beta, or alpha minus b plus square root of d divided by 2a, right? And beta will be, so this would be, beta will be the negative of d, so on and so forth. So we have, just a second, okay, this is, yeah, alpha is equal to minus of 6 plus root of, or let me just go with x itself. No, yeah, that would be better. Let me write this as x itself. Then we can decipher the answer finally. So plus or minus t is 12 divided by 2a, 2 into 3. Okay, so we have this to be minus 6 by 6 plus or minus root of 12. I can write it as 2 root of 3. 4 3 is 12, yeah. And this is 6, so on and so forth. So we have the final answer to be minus 1 plus or minus square root of 3 by 3. Right, done. Hence proved. Hence the statement is true. Okay, Done. Yes, we need to simplify always. You can't just leave it. So this is the simplest form. And if you guys are confused with how I got root of 2 root 3, so let me explain it over here. Root of 12 can be written as root of 4 into 3, correct? 12 is 4 into 3. Can I write in this manner? True, is it not? So root of 4 is 2 root of 3. Done. That's it. Make sense? Okay, so let me show this so that you guys can recall. Where is it? Yeah. AB whole to the power of n is a to the power of n into b to the power of n. Then instead of n, it is 1 by 2, that is root. And so I'm putting it across both the terms. And then root of 4 is 2 and root of 3 is nothing. So we just ended up writing 2 root of 3. And here I'm using distributive property. If you guys didn't figure out how I got 6 in both the denominators, we have to use distributive property. This entire expression has to be divided with 2a. Right? Makes sense? And so this is your answer. Okay guys, now you can pause and have a look at the answer.